Hi folks, welcome back to physics. It's our first full day. Today in class we're going to work on using some of the skills that we're going to need to be successful in physics. A lot of math skills and then some converting and learning some of the different terminology we're going to be using like speed, velocity, acceleration, and that type of thing. So up here on the top, notice you do not have to worry about rounding to the correct significant figure for this portion of physics. So we are usually just going to round to 1 or 2 decimals. It just kind of depends on the problem. As long as you're close to mine, it will be fine. All right, skill number 1, being able to put numbers into scientific notation. If you have really big or really small numbers, we're going to have to be able to look at them in scientific notation because a lot of times that's how our calculator puts it back out to us. All right, so the first thing is if we have a number in scientific notation, we need to put it into a normal way. You just need to look at the exponent. That tells you how many decimal places you have to move it over, and then you look to see if it's a positive or a negative. If that exponent is positive, you make the number a larger number. If that exponent is negative, you're going to turn it into a smaller. You'll move the decimal place to make it a smaller number. So for part A, expand 1.4 times 10 to the third. The 3 tells us we're going to move it 3 spots over. Positive means we're going to make it bigger. So we're going to move 1, 2, 3. We're going to fill it in with zeros. So 1400 will be that expanded number. For the part B, 5.2 times 10 to the negative 4. 4 is how many spots you're going to move. The decimal place, negative means make it smaller. So we are going to go 1, 2, 3, 4, which means we got to fill in with 3 zeros before we get to the 5, 2. So 0.00052. If you have a number, big or small, and you need to put it into scientific notation, you just need to count how many spots. Always the decimal place goes after the first number. So here, if you don't see the decimal place, it means it's behind. So we got to move it 1, 2, 3, 4, 5, 6. So 6.3, the decimal place always goes behind the first number, times 10, and then we moved it 6 spots. It is a big number, so it's a positive 6. The last one, putting that into scientific notation. You find your decimal place right there. You're going to need to move it 1, 2, 3 spots until it's between the 8 and the 7. So 8.7 times 10. And then you just have to count how many spots over you had to move it. 3 spots. It starts as a smaller number, so it's a negative 3. Okay, we are going to have to be able to do a little bit of trigonometry. In order to get this to work, please make sure you have your calculator with you. It has to be in degree mode. I know in some math classes you'll be switching into radians as well. In physics, we always need it into degree mode. Okay, always put your name on your calculator. I have permanent markers for you to use. If you leave it here, I will get it back to you. All right, for 2a, if the cosine of angle B is 4 divided by 7, what is B? Okay, the first thing that I do is I get it down to just one number. So I take the 4, I divide it by 7. So I have the cosine of angle B is equal to 0.571. If I take 4 divided by 7, I get 0.571. That is not angle B, that is the cosine of angle B. So to get your calculator to give it to you in degrees, to get just the angle, you have to inverse or second cosine of this number right here. So you hit second cosine 0.571, let's do the inverse. And if you type it in correctly, we've got an inverse, we are going to get like 55.2 degrees. Whenever you get your answer, if you would just box it in, it helps me find it a little bit easier when I'm grading things. All right, for triangles, you also have to be able to use Pythagorean theorem. Your a squared plus b squared equals c squared. The hypotenuse is always c. So when you look at this triangle, it doesn't matter if you go AB or AB, the long side is c. That is 14 right there. So I'm just going to make this equal to a. So I'm going to have 9 squared plus, this side doesn't have a number, x squared equals 14 squared. All right, some of you will be able to shove that into your calculator and get it to tell you a number. For most people, they just work it through. 9 squared is 81 plus x squared equals 14 squared is 196. Okay, to get x by itself, you have to first subtract the 81 to the other side. So I gotta subtract 81 both ways. I get x squared equals 115, but that's not my final answer. I want x, not x squared. So my last step, I'm gonna have to square root both sides, and I end up with x is approximately 10.7. You can have a different decimal place or have it rounded slightly differently, and it's okay. All right, you're gonna have to know how to convert. Okay, so you did a lot of this in chemistry, and for some people it's hard, for some people not as hard. So that's okay, you're gonna get good at it. We're gonna do lots of practice with it throughout the year. These are the conversion factors that we are gonna have to know and be able to use. The ones that I have starred are the ones that we use all the time. Okay, they are located on the front of your pink equation sheet. So you have them handy. You don't have to memorize them. It helps if you do because you go a little faster, but they are always available to you on the front of your pink equation sheet. Okay, our 1,000 meters in a kilometer and 100 centimeters in a meter. We used that last week when we were looking at our reaction time lab. And then to get, so those are metric system, but to get from the English system of feet and inches and miles into the metric system, we're gonna need 2.54 centimeters in an inch, 1609 meters in a mile, it's a strange one, but you'll use it a lot, and 3.28 feet in a meter. When you put something on a scale, the metric system, 1,000 grams in a kilogram, but our English system, to get from pounds to kilograms, we have to use 2.2 pounds in a kilogram. And then for our time unit, a lot. We are gonna use the 3,600 seconds in an hour. All right, so we are gonna set it up. I am starting for part 3, 46 kilograms. I wanna change that into pounds. So I am gonna start by running what I have. And then for me, depending on how you learned it, which teacher you've had, I like to set a conversion factor up like that. I know other people will set it up like that. Exactly the same thing. You can use whichever way you're comfortable with. They mean the same exact thing. I just like the multiply sign by it. All right, I want to change it from kilograms into pounds. Okay, because I start with kilograms, whatever I have on the top automatically has to flip to the bottom so that they can cancel out. What I'm looking for, I want to go to pounds, that has to go on the top, LBS. All right, from there, I look through my conversion factors. I want to go from kilograms to pounds. Right here is the one I'm going to use. For every 1 kilogram, there's 2.2 pounds. I just have to put the numbers with the correct unit. In 1 kilogram, there's 2.2 pounds, okay? Kilograms are here, and the top and bottom mean they're gonna cancel out. The only unit I'm gonna have left is pounds. And then you just have to remember, anything on the top gets multiplied, divided by anything on the bottom. So I'm gonna take 46, multiply it by 2.2, divide by 1, which you get to skip. And if you do that, I got a little over 101. I got like 101.2 pounds. And then once again, if you just box it in for me, I appreciate it. All right, if you look at the second one, I have 23 centimeters, and I want to change it into feet. Okay, I don't know how many centimeters are in a foot, but I do know how many inches are in a foot, and I know how many centimeters are in a meter, and I know how many meters are in a foot. So there's 2 different ways to do it. I'm going to use the way that kind of gets us into the metric system. Okay, so I'm going to start here. I know that to get meters into feet, I can get from meters to feet, and then I also know I can get from centimeters to meters. All right, so I just have to start with one of them. I'm going to start by going with the centimeters into meters. So because I started with centimeters, that has to flip to the bottom so it can cancel out. What I'm looking for, meters, is going to go to the top. And from there, I'm going to fill it in. For every 1 meter, there's 100 centimeters. 1 meter, 100 centimeters. Okay, if I stopped here, I would be in meters. I just need to get to feet. So I'm going to set up one more conversion factor. I now have meters here. That means that has to flip to the bottom so that it can cancel out. I'm looking for feet, so that has to go on the top. For every 1 meter, there's 3.28 feet. For every 1 meter, there's 3.28 feet. All right, meters are going to cancel out. I'm going to be left with feet here. In order to get the math to work, I take multiply across the top. So I'm going to take 23 times 1, you can skip that, times 3.28. And then I have to divide by numbers on the bottom, so I'm going to have to divide by 100 as well. And if I do my math correctly, I get 0.75. You might have it rounded slightly differently, feet. You could, like I said, you can go from centimeters to inches, and then if you remember that there's 12 inches in a foot, you could do it through those 2 steps as well. You get the same answer. I just didn't have the 12 inches in a foot, so I used the other way to do it. For part C and D, we have to be able to convert between our unit of speed and velocity, which is miles per hour in the English system. We have to be able to get into the metric system, which is meters per second. It's a 2-step conversion, similar to what we just did right here. All right, so for part C, I am going to take 58. MPH stands for miles per hour. Per means divided by. So the way we write it out, miles, MI, so that it's different from meters, which is just an M. Per means divided by, and then hour goes on the top. Okay, so make sure you write MPH as miles per hour to help you. Otherwise, if you put the hours on top, it's going to flip it and give you the wrong answer. All right, I need to change miles per hour into meters per second. Okay. It does not matter which one you do first. You can start and get the miles into meters or the hours into seconds. It will give you the same answer either way. I just always start with whatever I have here on top. Okay, so my first step, I want to change the miles into meters. I have miles on top, which means to cancel it out, it has to go on the bottom, and I want to change it into meters. If I scan back up here, meters in a mile, there's 1609. So in 1 mile, there's 1609 meters. Okay, you can't let the M and the MI mess you up. MI is mile, just M is meters, 1609 meters in 1 mile. If I were to stop right here, I would be in meters per hour. I want to get to meters per second. So I have one more conversion to do. So I'm going to set up a second conversion factor. From here, I need to change hours into seconds. Okay, here's the tricky part. Hours are on the bottom. To cancel them out, you have to flip it to the top, which means the seconds will be on the bottom, which is good because that's where I want it. Okay, if you don't remember, there are 3,600 seconds in an hour. In 1 hour, 3,600 seconds. Okay, hours are going to cancel out. All I have left is meters over seconds, so that's going to be my unit. And in order to do the math, I multiply across the top, 58 times 1609, hit enter, and then divide by on the bottom. There's a 3,600 that has to divide. If you do your math right, you get about 25.9. All right, hit pause on the video. I want you to try setting up part D and then flip it back on and see if you get it right. Okay, for part D, we're doing the same thing we just did. We're going to use 1609 and 3600, but we're going to go from meters per second into miles per hour. So we're going the other direction. Okay, so I'm going to start here, 35.8 meters per second. I'm going to need 2 conversion factors. I'm going to need to get, I'm going to need to get my meters into miles and my seconds into hours. So I'm going to need those 2 numbers again and get them set up. So pause the video, try it on your own, see if you can calculate it, and then check back. Once again, I just always start with whichever one's on the top. It's meters. So automatically, meters have to go to the bottom, and then I want to change it into miles, so that has to go to the top. In 1 mile, there's 1609 meters. It's the same one from up above in the chart, 1609 meters in a mile. My meters are going to cancel out. I'm going to be in miles per second, but I want to be in miles per hour. So I need to change miles. It's on the top, or excuse me, seconds. I need to get seconds into hours. Seconds starts on the bottom, which means it has to flip to the top. Hours then will go on the bottom. In 1 hour, there's 3,600 seconds. The seconds are going to cancel out. All I'm left with for units is miles per hour. I write it as MPH. You could have MI/hour. And then you just got to get yourself a number to go with it. I take the 35.8, multiply it by the 3,600, and then divide by the number on the bottom, the 1609, and I end up with about 80.1. There's a quick way to check to see if you did your conversion factors the right way. Whatever it is in meters per second, miles per hour are always a little more than double. Okay, so if you look at this right here, 35.8, if you double it, it'd be a little over 70. Okay, 80 is a little more than double your starting answer right there. So it's just a quick way to check it. The miles per hour are always a little more than double the meters per second. All right, skill 4, algebra. You're going to have to be able to solve for x. We're going to do this the most out of any of these things. You have to be able to move your variables around, or at least, start to refresh your memory on how to move them around. Okay, so looking at something like this, 3x plus 4 equals 16. First thing you have to do, we want x alone. We got to take the 4, move it to the other side. It is added, so we are going to have to subtract both sides by 4. So I'm going to have 3x equals 12 when I subtract 4 away from 16. From there, I need x alone. It is multiplied by 3. All I got to do, divide both sides by 3, and I should get x is equal to 4. What if you see something kind of like this right here? Okay, it looks like a lot of stuff. A lot of times people will look at it and say, okay, I need to take 2 divided by 6, and I need to take 5 divided by 30, get it down to one number. You can do that, but I highly suggest whenever you can, you cross multiply and divide, because people are used to that, we're really good at it. It tends to be the easiest way to solve any problem if it's available to you. So if you're going to cross multiply, doesn't matter which side you start on. I have 2x then times 30 would be 60x. Set that equal to 5 times 6 is 30. Right there, it just got a lot easier to solve. All I got to do is get x alone. I need to divide both sides by 60. And if I take 30 divided by 60, I get 0.5 or 1/2 for my final answer. All right, last step. You are going to be looking at these variables. Variables are the letter in the equation, and then the units that go behind your answer, what it's measured in. We're going to have to we're going to start memorizing them because they're going to be in our equations that we're going to start learning in about a week or so. Okay, so here are the definitions. Time, how much time something takes up, that is always measured in seconds. Distance, how far an object travels, it's always measured in meters. I'm just going to abbreviate it with an M. Velocity, we use speed and velocity interchangeably. They're slightly different, but we'll learn about that later. Velocity, how fast something is going, is always in meters per second in the metric system. And then acceleration is how fast you get faster. All right, it's the change in the velocity of the object divided by the time it takes. So it is meters per second, which is the same as meters per second squared. All right, here are the different variables that we are going to see in our equations. Horizontal is x, distance, it gets this delta in front of it, that means change in. So this x is horizontal distance, the delta means change in, so how much distance you traveled horizontally. If it's delta y, it's the change in the vertical distance, how far something fell. Y is up and down. Time, change in time, how much time has passed, delta t or triangle t. Initial velocity, how fast were you going at the beginning, is VI. Final velocity, VF, how fast are you at the end, and acceleration is abbreviated with an A. I'm hopeful that you have seen a lot of these before throughout ninth grade and stuff. Okay, what are things measured in? The unit that goes behind your answer. We just did it up here. Any distances in meters, abbreviated with an M, time in seconds, S, meters per second, any velocity or speed, M/S, and then meters per second squared for acceleration. It's the only one that has that squared function. So if it's meters per second squared, it has to be acceleration. You will need to be able to answer questions like, what is the unit for initial velocity? Look right here. You just have to make sure, does it say unit or does it say variable? Variable is the letter that represents it. Unit is the what it's measured in. Okay, so I want the unit for initial velocity. So the unit of how fast something is going, that's meters per second. The unit for acceleration is meters per second squared. If it had asked me for the variable for acceleration, then I would have an A. That's how you abbreviate it with the variable. Okay, I do have, and you're going to try it in some of the homework piece of it, I do have a variable practice quiz that you can take as many times as you would like until you start to recognize some of these things. We're going to go into them pretty heavy next week when we start working with our equations. And then the last thing, know that variables work just like numbers. If you have them on the top and on the bottom, they cancel each other out. Okay, just like we were doing with conversion factors. So if you look at this, if we have a velocity, meters per second, and we multiply it by a time in seconds, well, look at this. We have 1 second on the top and we have 1 on the bottom. We cancel it out and you are left with just meters. We're going to find when we take a velocity times time, we are solving for a distance. That's why those units do those things. And then finally, what if you want to divide a unit? Okay, dividing a unit, you have to think of it like a fraction. So I have meters per second divided by a second. Think of it as a second over 1. In order to get this to work, you have to multiply by the reciprocal. So this second over 1, it's got to flip off the bottom. You got to multiply by the reciprocal. So I still have meters per second up there on the top. Now I need to multiply by the reciprocal. So I'm going to have times 1 over a second. And this turns into meters are on the top. A second times a second is a second squared. Or you could just do meters per s squared. They're the same thing. All right, so they work just like units or numbers. You can multiply or divide the units as well. All right, so hopefully if you have any questions, you just know tomorrow in class, make sure you get them answered. Those are kind of the skills that we're going to be working on over the first week or so. Your assignment is the last 8 problems there. The first one in Schoology, there's a variable practice quiz. It's going through all this chart right here, and just until try it, you put your score in there, and you can do it as many times as you like in order to start remembering them. From there, there's a couple scientific notation. There's a few conversions, 4 of those, and then finally solving for x. Number 9, I think most people find it the hardest one. I highly suggest you can find a common denominator if you want to. I like to just put everything in decimal form. All right, so 1/2 would be 0.5. 1/4 would be 0.25. So you can get it all down to decimals, and then you can cross multiply and divide to get that x off the bottom. So once you finish, check your answers with the key in Schoology. There is a key and it'll be labeled as such. So try it all, and then you're going to go to the key and you're going to grade your own. And then if you get any of them wrong and you're not sure why, then you're going to check with me and I will help you through it. You can either, if you're absent, you can either submit it on Schoology or you can bring it back and check it out with me. All right, I think that's it. We are good to go. Thank you.